All right. It is with great pleasure that I introduce Doug N0DAJ, who is also Assistant District Emergency Coordinator in Yavapai County Aries Races. And he's going to talk about his amazing hybrid gateway in Arizona and how he tell us his story of how he came to build this gateway. So on the right here, you can see we're going to do a quick introduction. We're going to show you where he's located. Doug's going to tell us about the radio gear and power considerations that he went through in order to set this up. Antenna selections, very important. And then some special considerations at the end. And with that, I'd like to introduce Doug N0DAJ, the man, the myth, the legend. That was my choice there, right there. And that is Doug in front of his station. And Doug, please, your show, you take it away.
Well, thank you, Oliver, and good morning, Aries LAX, from sunny Wickenburg, Arizona, where it's already 105 degrees. So it's going to be a hot one today again. I closed my blinds behind me. I guess that's going to work okay. You can still see quite a bit of light in the window there, but I think it's going to be all right. So here we go. Why don't you go ahead and, well, first of all, this is my station before. It's changed a little bit, as you will see in some slides as we get to them. So anyhow, this is off of my QRZ page. So go ahead, Oliver, change the slide. As you can see, in the west part of the United States, there are not a whole lot of gateways. And if you look closely at the balloons, you will see some that have an H in them. That means that they are an HF gateway, which leaves even fewer gateways in the West. So that was one of my considerations when I started doing this a couple of years ago. So unless you have anything to add, Oliver, well, you can see just one more thing before we change slides there. You can see I'm about 65 miles northwest of downtown Phoenix. I don't know if how many of you are familiar with the Phoenix area, but we call Phoenix the Valley in quotes because it's called the Valley of the Sun. So all of us locals refer to going to Phoenix as going to the Valley. So if you hear me say that, you'll know what I'm talking about. Okay, Oliver. All right, this was kind of an interesting thing that happened, and Oliver, jump in here anytime you'd like. Oliver's friend Evan in Hawaii sent me this very interesting connection. He connected to me and KO000 up in Las Vegas, and also to KL7EDK in Alaska from his location in Hawaii. As I understand it, Evan is on the east coast of Hawaii. Is that right, Oliver?
Yeah, but he's got a mountain location, so it's really good.
Yeah, he's got a mountain location and he has a lot of water, which makes for great propagation. He has successfully connected to me several times on 20 meters from his location in Hawaii, which I found pretty amazing to begin with. Now, keep in mind that in an emergency situation, this would probably not be a reliable path. However, it could be. So always keep that in mind. HF is very fickle. Let me put it that way. So we'll talk more about that as we go on here. As you can see, I have 3 VHF, UHF gateways, and I have HF gateways on those frequencies. The 14115 is a Vera 500 frequency. The 14103 is a Vera 2300 frequency. Same way as the 40 meters, the 7108 is the Vera 500, the 7103 is Vera 2300, and the 80 meter is backwards. The 3587 is the 2300, the 3584 is the 500. Why did I select these frequencies? Well, I only have limited choice. Frequencies on the HF bands, there are only certain frequencies that are allotted for automatic forwarding, and you have to be within those frequencies when you set up your gateways. Uh, when I set up my 500 frequencies, which I have just done recently because of a request from someone else, I can't remember who, that said we didn't have enough 500 gateways. I stayed outside of those HF forwarding frequencies. That doesn't mean my system won't forward the message, but I stayed outside of those frequencies to leave the forwarding frequencies more available. So unless you have anything to add, Oliver, we'll go on to the next slide.
Well, I just want to say that it takes two to tango. One, Doug's setup is really robust and really great. And Evan, for those of you who are interested in what Evan's setup is, he used 30 watts off of a battery on an MCOM Chameleon 2. So understand that Evan is testing this in terms of what can I deploy after hurricane. So he did not use his main setup, but he actually used a field setup to make this connection. And from Evan's description, he says the 20-meter connection with Doug and K00000 actually extends his reach by 2 hours. There was a 2-hour window, and you can see that here in Hawaii, between 6 and 8:30, where he had a tough time finding propagation on 40 and 80 meters. So Doug and Richard are actually bridging that gap. So keep that in the back of the mind as we move forward. This was done with an MCOM setup, whereas to Doug, who's got this great permanent setup. All right, I'll go up to the next slide.
All right, this was another interesting that happened just this week. I received an email from Dieter in Australia asking me a couple of questions about my gateway because he had connected to it. And his main question was, he said, I looked you up on QRZ and I see your equipment, but I don't see anything about antennas. So he says, what are you running for an antenna? Well, my answer to him was a Alpha Delta DXCC, which we'll talk about later, with the apex at 40 feet and in an inverted V configuration. And I'm running a Kenwood TS570 at 75 watts. And he wrote back to me and he says, wow, that's amazing. So you can see some of the paths from Dieter here in Australia into the US, again on 20 meters. And he said that his best time of day, he has 2 openings where he has very good success with the US. And that is at 2000 UTC and again at 500 UTC or vice versa, however you want to say it. But interesting. Notice the bottom line there that goes over to Texas. That line there goes to our super gateway down in Texas, N5TW, Tom Whiteside. He, if you get a chance to go to QRZ, look up his page, November 5 Tango Whiskey, and you'll see his antenna setup. Puts mine to shame. That's putting it mildly.
Yeah, but either way, you know, Dieter made a good connection. And by the way, we talked about that yesterday. I looked him up. He's a German RF engineer who used to work for Nokia.
Interesting.
So it's kind of cool. But thank you so much, Doug. Shall we go on?
Yes.
Awesome. All right. Tell us a little bit why you became a Winlink sysop.
Well, as you can see in my little paragraph here, Yavapai County, Arizona is about 8,500 square miles, and it's divided into by mountains into about 3 sections. I live in the southwest corner of the county, really in the corner. I'm only a half a mile from the Maricopa County line. Maricopa County, just for those of you that don't know, is Phoenix, basically. I first put up VHF gateways when we lived at our former residence about 8.5 miles up the road. That particular location did not have an HOA, but we did have antenna height restrictions. So I was able to put my HF antenna up at 20 feet at the apex, and I had several VHF antennas up, and some of them actually were higher than 20 feet, but I got away with it. So I decided to start the VHF gateway because of my location and our distance from Prescott, which is our county seat and where most of the population of Arizona or Yavapai County lives. I put those gateways up for our local folks here, my local Aries Races group. So they had a way to use Winlink without having to try to get to Mount Union, which is our main hub for Aries Races Winlink communications. After doing that, after a couple of years, and after we moved into this house, one of the criteria when my wife and I bought this house, the first thing I told the realtor was, don't even bother showing me a place that has antenna restrictions. And so that was a top criteria for us locating this property. After I moved in here, about a year after I moved in here, I put my tower up, which you will see later. And then I decided that after looking at the Winlink map, that there were, virtually no HF gate. Well, first of all, there was no HF gateways in Arizona. And secondly, there were very few in the Western United States. So being a MCOM type person, I enjoy ham radio, and as we all know, there are a lot of phases to ham radio that you can get involved in, and everybody seems to pick their niche and land there. But being an MCOM type person, I really wanted to get this accomplished, to have both an HF and a VHF gateway. And as it says in the last sentence there, that this was all done in the interest of emergency communications, but it does provide a great service for any ham on a day-to-day basis. I looked at my log for last month. I think I had 353 hits in the month of August on my gateway. Now, that does not mean 353 separate call signs, because a lot of those were repetitive, but nevertheless, it's 353 successful connections to my HF gateway, which I think is pretty fair.
I would say that's excellent. Tell us a little bit about your radio gear. Let's move on. Here's your main station for VHF. Walk us through that a little bit, please.
Okay, well, up on the left-hand side there, by the way, you can see that no ham shack for anybody that's older than about 40 years old is not complete without a Motorola speaker. You can just see it in the corner there. I still love those are still the best quality speakers ever made. Anyway, that stack next to the Motorola speaker there, first of all, in front is my ICOM 2720, which is my just my communications radio for VHF. I use that for nets and weather net and all that sort of thing. Behind it is on the bottom there with the 145-710 is a Motorola CDM 1250 VHF commercial radio. And that's kind of an interesting little story, because the company that called repeaterbuilders.com, I don't know if any of you have ever been on that site, but there's two guys that basically own that company. And one of the guys builds the DRA boards, which Oliver and I both have. And the other guy, Scott, builds what's called a rim light board. He makes a board that is actually a TNC, and I wish I could show it to you, but I can't. That's very small. It's smaller than the DRA, and it plugs right into the accessory connector on the back of the CDM 1250. And all you do is connect a USB cable from there to your computer, and that's your gateway. It's pretty interesting. Above that is my Yaesu 2200, which is on 145.01. Above that is an old ICOM IC48 on 441.3. Now, normally 441 frequencies are considered to be 9600 backbone frequencies. However, my gateway is a little different. It's 1200 baud packet. And the reason I did that was very simple. It's just a local gateway. It's not connected to any digipeaters or anything else. It's just for my local folks here. And I did this for the purpose of local training, mainly. And the reason I say that is you guys are already doing this and you know how well it works to use voice communication along with packet traffic. Hey, so-and-so, I'm going to send you a message. And so-and-so answers and says, yes, I received the message, and I'll send you a reply. Well, it's not really legal to use voice on 145.010 or 145.71 because they are designated data frequencies. However, in the 440 band or the 70 centimeter band, there are no frequencies designated specifically for data. 441.3 is actually a repeater input or output frequency, but I checked the repeater book very carefully to make sure that there were no repeaters within 50 or 100 miles of me that were on 441.3 before I chose this frequency. It's worked well. I've never had any interference from any repeaters. And having said that, we can use voice over packet on this frequency for local training purposes. Works well. Down in the right-hand corner is my TS570, which is my HF gateway. And up on top of the radio stack there, I forgot to mention, you will notice KPC3, which is connected to the 440 radio. The bottom signal link is connected to my HF radio, and the top signal link is connected to 145.01. So it will do Vera, but it won't do high-speed Vera. My signal links are the older versions, and we're going to talk about that later. So I'm not going to, but somebody else is. So, okay. These are my gateway screens, and you will actually see one of my screens live here a little bit further on in the presentation. On the left-hand side at the top is RMS Relay. That program is used to for a very specific purpose. It connects all of my gateways. All of my gateways are connected to RMS Relay. And RMS Relay's function is to monitor the internet. If the internet goes down, if you connect to any of my gateways with the internet down, first of all, it will send you a warning message that says no internet connection. Now it will say messages will be forwarded via HF. That's a very important program. Everything runs through that. Down in the center there, that little screen is just a waterfall that shows RDOP. I like to bring that up and watch it to see traffic on there. The bottom part of that left-hand side is my HF gateway. That is the RMS Tri-Mode. And it is a program that you will see better up close a little later that will allow robust packet, PACTOR, WinMore, Vera, and RDOP. I have turned off the Vera portion of my gateway. I'm sorry, the WinMore portion of my gateway since the Winlink folks have deprecated that program. I figured I might as well do it right away, so I did. Anyway, we'll talk about that a little more later as well. On the right monitor, well, oh, I missed one thing. Up in the upper right-hand corner right there is my UHF gateway. On the right-hand monitor is simply my two VHF gateways, and the screens or the boxes below them are UZ7HO, which is a sound modem program that operates with a sound modem type device like a Signal Link or a DRA board or anything like that, or the Rimlight board. Okay, Oliver, go ahead. This is just a chart that I threw at Oliver yesterday and asked him to put in here after we talked, showing some of our gateways in Arizona. You notice we have quite a few gateways in the Prescott area, the Mingus Tanks, Mingus Mountain, those PVPD is Prescott Valley Police Department, Mount Union. Those are all in the Phoenix or in the Prescott area. The Cornville is on the other side of the mountain, on the east side of the valley, as well as Mingus Mountain also feeds the east side of Yavapai County as well. And then we have connection to Joe, W7LUX in South Flagstaff, via some digipeaters on Mount Eldon, which is up north of Flagstaff. So just again for clarification, we have a couple of gateways, one in Central Phoenix, one in North Phoenix, and then we have digipeaters on Mount Union, Mount Eldon, Squaw Peak, which is northeast of Prescott, more east than north, and White Tanks, which is in the West Valley area. I can almost throw a stone and hit White Tanks from my house. I'd have to have a pretty strong arm, but I can bring up the White Tanks repeaters on low power inside my shack with an HT. That's how close they are. So
Nice.
that's a real good location for me. Okay, Oliver, any questions on that? It's, you know, probably not. It's just a little information, that's all. This is what my ham desk looks like now. A little different than it did in my QRZ picture. Just a couple of things I'd like to point out. On the left-hand side there, next to the monitor, you can see a two radios there. The bottom one is 144.99, which is our local search and rescue APRS frequency. They have several digipeaters, and I monitor their activity on APRS. The one above it is my FTM 100, which is a system fusion radio, plus being as well as being a conventional VHF UHF dual band radio. I really enjoy fusion. I have a good friend down in Gilbert, Arizona, and we get on there and yak all the time. So it's a fun mode. Right underneath, it's hard to see, move your pointer over, right there is another CDM 1250 Motorola that I use for GMRS. And then directly below it, mounted to the board there, is my ICOM 706. That's the radio I use myself to check into gateways. This is my local communications radio besides my ICOM 2720 over there on the right-hand side of the monitor. On the monitor, I use SAR-Track for my APRS program. I chose that a long time ago when I used to be part of Yavapai County Search and Rescue, and I've kept it because I like it better than any of the other APRS monitoring type programs that I've run across. The right-hand side of the screen is AGW Tracker. I like to look at raw data as well as people being tracked going down the road. So that's it. Oh yeah, I was going to warn you about this picture before we brought it up. Yeah. Mm-hmm. This is a typical story in most hams lives that have ham desks like I do. You know, you try to do the best with wiring as you can, but there's only so much you can do. No matter how good you try, it just is a mess. A couple of things to point out there. Oliver has the red dot on the RF choke that is connected to my HF rig. And I'll kind of stop here and talk a little bit about RF in the shack. When you run HF radio, seems like particularly on 40 meters, tends to get into things like computer speakers, and in my case, weather stations and TVs and everything else. I had a real problem for a long time after I set up my HF gateway with RF turning on my TV in my shack. I'd be asleep in the middle of the night, and 2 o'clock in the morning, all of a sudden I would be awakened by my TV coming on in my ham shack. That problem, I fought, tried different things and never did cure. Turned out to be the TV itself. A lot of electronic equipment these days, seems like particularly TVs, don't have very good shielding. I finally cured that problem by swapping it out for a different TV in the house, and I've never had any problems since. This choke I put in there at the recommendation of Mike down in Baja, because I was continuing to have RF problems. And also, Oliver, if you could go up to that ferrite coil on the power lead. Palomar Engineering out in California there. I can't remember where he's at. I think it's same place that that our friend, I can't, just had a senior moment. The famous ham guy that does all the presentations. Help me, Oliver. Lives in Costa Mesa.
Yeah, just keep going. It'll come to you. Well,
yeah, I know. I'm having a senior moment here.
It's
anyway,
Gordo.
Palomar Engineering.
It's Gordo.
Lou says it's Gordo.
Oh yeah, Gordo. Yeah, very
Thank
very
you, Lou.
good. Thanks, Lou. Anyway, Palomar Engineering, I believe, is in the same city that Gordo lives in, and they produce a lot of kits for different HF radios, which include ferrite beads, ferrite clamp-on beads, and these ferrite coils. You'll notice that my power cord for my TS570 is wound around a number 31 ferrite donut, you might call it, and that helps with RF as well. Couple of things there. The power box that Oliver has the red dot on right now, we'll talk about that in just a minute. You can see some leads coming out of it that kind of make a loop down and then go up and to the right, and up there is a real mess, but that is the positive bus that comes off of that fuse box, and laying up on top of the shelf is the negative bus where all my equipment is connected to. So that's about it. You can see it's a mess, but that's the best I can do. I probably could do better, but anyway, moving on. My fuse panel is a little unique. I'm a former Ford Senior Master Technician for almost 46 years. I retired in 2012. And my specialties in all those years, my all-time specialty was electrical work. When I started in the business when I was 16 years old, I started at the Ford dealership my dad worked at. When I was 16, I worked part-time while I was still in high school. And I was always the electrical guy. I had a service manager for many years that used to say I could smell a short in a car. And so that electrical expertise evolved, of course, into electronics as vehicles started to use electronics to control first carburetors and then electronic fuel injection. And my other specialty, which has nothing to do with what we're talking about, was heavy engine repair. So that was kind of my three areas of specialty, although I did anything and everything. This fuse box is out of a 96 Explorer that was in a really bad front end collision. And it has, or it had a wire harness that was about 1.25 inches in diameter coming out of it that ran along the, this fuse box was located on the left front corner of the vehicle, and it ran along the left fender and then curved around towards the firewall. And in that accident, that harness just about was cut in half. And actually, you can't see it, but there's part of this fuse box that's actually broken because it was involved in that front end collision. So when I pulled the box and the harness out, I just kept it and had it under my toolbox for several years. And all of a sudden I decided that that would make a pretty good distribution panel for my ham shack. So there it is.
Excellent. And Doug, while we're at this, we're coming back to the power options later, but at this point, I think people will be interested in how are you powering the station? What are you doing for backup power?
Okay, well, the station is powered by most of the time by a 30 amp Astron power supply, 35 amp Astron power supply. But I have a power gate connected to it as well. They call it, and now I've forgotten the name of it again. I had it the other day. Boy, I'm having real senior moments this morning. Epic Power Gate. It came to me. It's called an Epic Power Gate, and you connect your power supply, you connect a battery, and you connect a solar panel to that Epic Power Gate, and it will automatically switch over to battery when the shore power goes away. And then, of course, the solar panel will be used to keep that battery charged. Right now, I only have a 100-watt solar panel on the roof of my house, and which you'll see some pictures later, and one battery. I am going to upgrade that. I purchased a couple of 250-watt solar panels for $75 each back in late May. There was a company down in Chandler that had them on sale, and they're used, but they're all in good shape and tested. So they're standing in my garage right now waiting for cooler weather. And I'm going to have to buy a different controller because my Epic Power Gate will only handle 30 volts max, and these panels put out like 37 max. So I'm going to have to get a different controller. So anyhow, that's basically my power. My computers are all on UPS backup units. I have one 1500 watt and one 1300 watt backup unit. So my two computers are each on a separate UPS backup. So hopefully they'll last until I can get my generator started.
Excellent. And thank you. We'll circle back to the powers a little bit later as well. So now, of course, the key of keys, antennas. And we know you have a very fun and exciting antenna setup. And before we move on and show you the pictures, no envy, okay? I know but I'm not showing it. All right. Doug, tell us a little bit about your antenna setup, please. Go ahead.
Okay. Well, this is the front of our house, basically, and we live out of town. We're in a rural area. We're actually in horse country, although we don't have horses. I do have a horse barn that I use for storing my trailer, but we're in a rural area. And again, when we purchased this house, the first thing on my list was no antenna restrictions. So after about a year of living here, actually it's been 3 years ago in July that me and three of my friends put up my 40-foot Roan 25 tower. And on top of that, or not actually on top, but there we go. Those two antennas on that outrigger setup there are homemade copper pipe J-poles. They're made of 1/2-inch copper tubing. And, you know, as you might imagine, in today's market, they're kind of cost prohibitive because of the cost of copper these days. These antennas are probably 20 years old, so they were built when copper was affordable, and they've served me well over the years. So those two antennas, one is on 145.01 and the other one is my 441.3 gateway antenna. So
they're used for the gateways.
Yes, they are used strictly for the gateways.
Excellent.
The tram, we're going to go to the 6 meter. Okay, there's the 6 meter arrow beam, 6 meter 3-element beam that I have up there. What's the next arrow there, Oliver? Oh, that's my dual band tram antenna. That's my main communications antenna for 2 meter 440. So that's the one I use the most. As you can see, it's the highest. And if you saw the terrain around my house, you would understand why. We actually live on the downside of a hill. And my 40-foot tower is really only about 20 feet above average terrain. So it is, I wish I had added another section to my tower, but hindsight's 2020. That's my Diamond X510, which is another great dual band antenna that is used for backup communications. That's connected to my 706. Go ahead, Oliver. That's a Ringo, a full-size Ringo, not the shortened version. This antenna is about, I don't know, 12 feet tall or so. And it is used for my 145.7.1 gateway. And the picture's a little deceiving. It is pretty tall. It's almost as tall as that X510. So it sticks up in the air pretty well. That is a G5RV Junior there with the orange line that comes off of that pole. I use that just as kind of a backup HF antenna. You can see a couple of TV antennas on those poles, one on that one and one on the garage. I'm cheap. I don't spend money for Dish Network or any of those services. My wife and I are plenty satisfied with antenna TV. We get about 60 channels of TV out of Phoenix down here. So that's good enough for us.
Fair enough. I think that, but I think, it's just nice to actually see the amount of antennas you can put up when you don't have any restrictions.
Yeah,
So
it's
I think
nice.
this is really cool.
Yep.
All right, let's do HF
Okay.
because, that's a fun part. And by the way, before we move on, I do want to point out Doug is running a hybrid network or a hybrid gateway. So anybody who can connect to his gateway on the VHF side can actually forward that information outside if the internet is gone. But let's talk about how that works and what kind of antennas you use to make that even happen. And by the way, this is my mistake. It should be 80 to 10 meters, not 80 and 10 meters. So this antenna covers 80 through 10 meters. So sorry,
Right.
I haven't updated that.
Yep. That's an Alpha Delta DXCC 80 through 10 dipole antenna. And in the next picture, you'll get a little better view of it. And I'll explain some of the legs of that antenna. It's a multi-band antenna. And I use that antenna is strictly used for my HF gateway. It hooks directly to my TS570. There's no antenna switch or anything in between it. And fortunately, my 570 has a built-in tuner, which works great for this particular application. I should expand on that just a little bit. When you're running a gateway on multiple frequencies, you have to use a radio, unless you have a really good antenna that's tuned really well for all the frequencies you're going to use. You need a radio with a built-in tuner that can individually tune those separate frequencies on separate bands and remember that tuning process. So when my radio switches through its cycle of frequencies, all of those frequencies are tuned and the memory in the radio remembers how to retune for each frequency. That's very important. Okay, go on, Oliver. That's an 80 meter half wave 80 meter dipole. It's 133 feet long. And this is the first place I have ever lived in my life. I shouldn't say that. In my ham life, before I was licensed, when I lived in Illinois, my property actually had room for this antenna. But in my ham life, this is the first place I've ever lived that had room enough for a full-size half-wave 80-meter dipole. I use this antenna a lot on 80 meters and 75 meters. Of course, I check into a Racy's net, Arizona State Racy's net every Sunday morning before I leave for church. And I also use this antenna to do my own HF digital check-ins. And I'll stop here. Yavapai County Aries Racy's, along with a voice net on Monday night, we also have a weekly digital check-in net for VHF and or HF or both. I use this antenna to check other gateways to check into that net, mostly KO000 Richard up in Las Vegas. So, and then there's a G5RV dipole there, which is the, I think in the next slide, probably.
Yep.
A full-size G5RV. There we are. You can see the orange line going to the left there. And Oliver wanted me to point out that that full-size G5 RV has about 36 feet of ladder line that is supposed to be hung straight down. And since it's a steel tower, you notice that ladder line is spaced about 18 inches or so away from the tower. And that's done for, of course, a reason, to keep the signal from being absorbed by the metal tower.
Very nice.
Whoops.
And so this is the antenna setup. Do we have any questions about the antennas at this point, or shall we move forward?
I did want to talk a little bit more about the DXCC. You can see it a little better in this picture, Oliver. We
Okay.
talked about that yesterday. Move up a little bit there. No, that's the 80 meter. Go to the separators down here below your, to the right of your orange arrow, or
Here?
to the left. Looks better. You can see them a little better right there. You notice the separators in the antenna there. That antenna has 3 legs. The long leg is 40 meters, and then there are loading coils at the end of it, and another 5 to 6 feet of wire for 80 meters. Then there is a medium length wire that's separated by those separators for 20 meters, and then yet another length of wire separated by those separators, a very short length for 10 meters. And of course, if you remember your any of your ham testing, you can also do 15 meters with this antenna on the 40 meter section. 40 and 15 will operate on the same antenna. So this antenna, I will point out, and that's the reason why I chose the frequencies I did. This particular antenna will not tune with my radio on any of the WARC bands. What do I mean by the WARC bands? Well, those were the bands that were added later on, 30 meters, 17 meters, and 12 meters. I would really like to have gateway frequencies on 30 meters. 30 meters is a really good frequency to use for HF gateways. However, again, my radio will not, and my radio and this antenna are not compatible on 30 meters, so ain't gonna happen.
And that's a good point to point out. There's always a compromise to be made. There's no perfect, but those are conscious decisions that you have to go through, right?
That's correct. Yep.
All right, shall we go on and show people what can you actually reach with those antennas?
Oliver, we actually have a question in chat, but
Okay.
maybe give everybody a moment to, if they have any questions with regard to antenna, radio, or power, the equipment side of things. We have a question from Brian. Is there a recommended TNC for a 2-meter gateway?
That's a very good question. Any TNCs will work these days. At this particular time, as things progress with Vera, and Oliver, you can agree or disagree with this, but we are probably recommending the DRA TNCs right now because they are the latest and greatest, and they are backwards compatible to conventional packet radio. However, if you have, or you can find a, I'm trying to get this in the center of the screen here. If you can find an old KPC3 at a Hamfest for 20 or 25 bucks or even 50 bucks, these are still very, very good TNCs, but they will only do conventional packet. Just keep that in mind. It's a good starting place, and it's always good to throw in your Go box for a backup. So, and of course, the Signal Link is an excellent choice because it will do both HF and VHF as you progress, as well as the DRA boards will also do HF and VHF as well. So things to keep in mind. I hope that didn't confuse you, Brian, but that's kind of my answer in a nutshell.
Thank you, Doug. We have another question from Brent who says, I expect you get a lot of lightning, I'm sorry. What do you use for protection and how well does it work?
Yeah, I should have included in that that in my slide presentation here, and I apologize for that. But at the bottom of my tower, I have each coax connected to a lightning device. Most of the devices are either Radio Shack or OPEC, which is a Chinese company. They are discharge units. It's just simply an inline unit that your coax goes through, and the unit itself is grounded to the tower. That unit has a gas charged cartridge in it. So if it detects a fairly good lightning strike, it will blow that gas charged cartridge and short directly to ground. So keep in mind though, that nothing will protect you from a direct strike, nothing. So that's always a consideration. And you notice that I'm pretty high up here and out in the open. What these gas charged cartridges do is, before they completely blow, they will also do something that's very, very important. And a lot of people don't realize that this happens, and I didn't either in my early ham career. I've got to stop and tell you a little story here. Early on in my ham career, I had a modified CB antenna on the roof that I modified for 10 meters. Because back then I was only a Tech Plus and 10 meters was the only HF band I could use. And of course, that antenna stuck up in the air and I didn't have any type of lightning protection on it at all. So I used to disconnect the coax from the radio when I wasn't in the ham shack. And one day I was down there and that was when I lived in Colorado Springs. And in Colorado Springs, it's very typical in early afternoon to get an afternoon thunderstorm. So I was down in my ham shack one Saturday afternoon about 1 o'clock, and I noticed, you know, clouds were building over the mountains to the west, which was typical. And all of a sudden I hear this snapping noise. And I'm looking around in my ham shack, what the heck is that? You know, and it's going snap. And then it pause and then it snap. And all of a sudden I looked down at that coax laying on the floor. The snap was a spark jumping between the center conductor of the coax and the shield. Ooh, yeah. And what that was is static electricity that builds up when there's an approaching thunderstorm and wind blowing across your antenna. So what these static discharge units do is they bleed off that static. By bleeding off that static, it is less likely for lightning to strike your antenna. Less likely. Not a guarantee, but so basically these antennas are connected 24/7, 365, and whatever happens, happens. You know, if I ever get a direct lightning strike, I'm going to be replacing antennas and equipment and so on and so forth. But as I said, those gas discharge tubes do help a lot.
Thank you, Doug. Any other questions for Doug with respect to his setup and his equipment before we move on to propagation? All right. Thank you. Oliver, you're up.
Okay. Well, I mean, don't have much to say about this in as much as you've seen the equipment, you've seen the antennas, and then the question is, how does it relate to ARES LAX? And it should be the BOA coverage map of N0DAJ.FO, but we'll change that. So just the thing here is we modeled Doug's setup, and on the other end, because it takes two to tango, we modeled what a basic field deployable antenna on 20 watts with the antenna being 5 meters or 15 feet up in the air. And this is what it looks like. So at noontime, his propagation is relatively local, but he's got good 80-meter coverage for the local area. And this is Pacific daytime. And then at close to midnight, an hour to midnight, you can see how much the propagation from Doug's QTH increases. So he's covering about 2/3 of the United States all the way to Hawaii on 80 meters. And that's kind of something to keep in mind. With HF, propagation changes during the day. So knowing when to reach Doug on which band is a good thing to know. And that leads us to the next slide, unless Doug has a comment about this.
Oh, go ahead, Oliver.
All right. So this is again from LA to Doug's gateway. That will change. That graph would change depending on what your location is. But this was modeled right to us here in Pasadena. Let me explain the axes real quick. On the vertical axis here, you've got the bands, 80 meter, 60 meter, 40 meter, 30 meter. In this case, 80 meter and 40 meters are what Doug supports with his gateway, right? As well as 20 meters. And you can see there's practically no propagation here. And this is a reliability estimate. And on the axis around, so to speak, you've got UTC time, right? And remember, we're 7 hours behind UTC currently. So our midnight would be 7 a.m. UTC. And then 1900 UTC would be our midday, our noon. And what I want to point out down here is the legend. So you've got 100% is the deep red. And you can see Doug's coverage of us in LA. And I'll have a red dot on red background. That doesn't work, right? So on 80 meters is pretty much all day except for these 4 hours midday, right? So from about 11 a.m. our time to about 2 p.m. in the afternoon is when we can't really reach Doug on 80 meters, but we can reach him really well on 40 meters here. And again, red on red. So Doug has, from an LA point of view, on 40 and 80 meters, 24/7 coverage. So just keep that in mind. Is there any question about this right now? Pretty straightforward.
Before you move on, Oliver, come here, dear.
Pardon?
I'm going to introduce my lovely wife. Get in the picture here. Can you see her? There she is. This is Joyce, KE7UUV.
Hi, Joyce.
Hi, Oliver and Sean.
And
Hello.
I will say that this lady is the ham's dream as far as a wife is concerned. She has supported me 1000% in my ham radio activities, along with being licensed herself, which is something she never thought she would ever do. So I thank her very much.
Part of what you, when you say I do.
And you did. Now you can't get up.
No,
Well, thank you so much for sharing him with us.
Can I just inject a comment?
Go ahead.
Go ahead.
That is that, as you heard Doug say, he has repurposed those items from his previous life of that being the auto tech and from various different things. And so we find new homes for a lot of old things.
Well, it's about being creative. And I think that's what's part of the hobby and part of the emergency communications spirit, to make something amazing out of the things you have around your home that maybe sometimes you don't even think about.
Well, being having a mechanical background and an electrical background, I do that a lot. So let's go on.
Well, you bring the skills to the party, and I think that's the fun part. All right, and just to drive that same point home, here's the VOA reliability path estimate. Again, we modeled it on 25 watts with a dipole at 5 meters above the ground. And so 80 meter coverage really well. Again, it drops off kind of midday and then comes right back. And in the time where you can't really reach this, it's actually the propagation is better than this, but you can reach Doug's gateway on 40 meters. And just to keep in mind, 20 meter coverage for us would be pretty unlikely. We can certainly try that, but I just wanted to show you that. And now we're coming to the next fun part, I should say, the N0DAJ demo. Shall we do that?
Hang on just 1 second, if you don't mind. As the sunspot cycle starts to swing up, we should see an increase in 20 meters. And one other thing I wanted to mention is keep in mind the word estimate in that. Just because the path says it's good doesn't necessarily mean it's so. So, this would probably be a good place to inject this before we go any further also. I just happen to think of something. When you are connecting to an HF gateway, you have to keep one very important thing in mind. We're going to talk about some more important things later on, but this is very important. An HF gateway has what's called a dwell time. And that means the time it takes to switch from one frequency to another. So if you look at your HF propagation prediction in Winlink, and it says that you have a good path to N0DAJ on 3587, let's use that as an example, and you say, okay, go ahead and connect, and you don't get a connect. Well, that could be caused by two different things. The first thing you think of is propagation. Maybe the path that the propagation tool is telling you is not exactly accurate, and that could be true. But the other thing you have to keep in mind is the dwell time for my station. My station might be on 40 meters at the time you try to connect on 80, which means that it has to go through two 40-meter frequencies, two 20-meter frequencies, and then come back to 80 meters. So if you don't get a connect the first time, hit that button immediately again and try to catch it in the cycle. Something very, very important to keep in mind when you're dealing with HF gateways. And the more frequencies an HF gateway runs, the longer it takes for that to come back to the frequency that you want to connect to.
And I think that's a good point actually to point out again when we show your gateway. And if you want to, I stop the screen share on my end. Feel free to share your gateway screen and walk us through and actually show us how your gateway cycles through, because you can actually see it on the RMS tri-mode. You can see that.
Okay, can you see the screen? There we go.
Right. And before we move on, Tom, are you in a situation where you could try and connect? I mean, we're actually getting to the end of that window, right?
I can. I'll have to. I can't do it. I can't screen share from.
But if you try to connect, we can actually see it on Doug's screen right now.
Yeah.
Oliver?
Let me.
Oliver, I think KQ in the chat said he was able to connect. He might be already set up. Mike, are you set up?
At the moment, I'm set up for 80 meters.
Yeah.
I can give it a shot.
Yeah, 80 meters is good. Mike, give it a moment, and Doug, please walk us through those windows. And when we get to the tri-mode, we can try and do a live connection. And again, this is HF, so anything might happen. What will we see?
That's right. Well, here I'm moving my mouse here. So here is the RMS relay window, and when whoever, either Tom or Mike, tries to connect, you will see their call sign come up at the top part of this window as a connection. This window in the center is just the waterfall showing RDOT, and you will see some activity on that window even if one of these two guys tries to connect on Vero, which I'm sure they will. Down here in the tri-mode window, if you watch the dial frequency and center frequency, you will see how my station cycles through frequencies. And this is all done automatically. The radio is doing this by itself through control through the Winlink software. Right now it's on 3585. Now it's going to 7101. Actually, you have to look at the center frequency. That's the actual gateway frequency right there where I have the mouse pointed. And you can see how long it takes for the gateway to cycle through those frequencies. It's about 6 seconds in between frequencies. Dropping down here, you notice that I have Winmore turned off. I do not do robust packet or PACTOR because both of those modes require that $1,500 German modem that I'm too cheap to spend money for, and refused to do. So I was very, very happy when the Winlink development team came up with Winmore to begin with, and now Jose with his Vera program is just fantastic. So here you can see right now, you saw it just switch from Vera 2300 to Vera 500, and that correlates with the frequencies of the radio up here. You can see the last two connections on each of those modes. Then we go down to the actual window itself. The last connection was KL7RI at 1708.51 UTC. So that was the last connection to my gateway. And you can see that it did transfer a message. It says transferring binary data to Vera TNC. You will see that, probably not see that unless Mike or Tom sends me a message. But so go ahead and try the live connection. Let's see what happens.
Right.
So Mike has tried and is not not able to connect on 80, but he's going to try again, urging by Jeff here. Go for it. So something I don't quite understand, Doug, when you say it cycles between the different frequencies every 6 seconds,
Right.
does that mean that, you know, I have to catch the right 6-second window, or?
Yep.
Okay.
That's exactly right. And that was the point I was trying to make before, is that you have to catch that 6-second window.
And let's have Mike try, and after that we'll have Tom try and see what happens. And again, this is HF propagation; it changes.
Yep. It may not work.
I'm trying. I had my computer set up for my demo with my RMS gateway, so I have to take all that down. So bear with me.
Oh, sorry, Tom. We don't want to make it any more complicated than it needs to be. If it doesn't happen, it doesn't happen. That's perfectly okay.
Thank you, Oliver, for keeping us on our toes.
Well, you know, it's one of those things. Live demos are always risky, but I think I'd rather show the demo. And, you know, again, we said earlier, there's no guarantee. And again, we're coming in the time window to where that propagation also changes from us to Doug.
Yeah, if either of those guys want to try 40, they might do that too. But we don't want to take up too much time here. We're already at almost 10:30. So.
Right.
Yeah, I'm not having any luck here.
Okay.
Yeah.
Then let's call it, Tom, and give you a chance to switch back for your presentation. And Doug, is there anything else you'd like to point out on this screen? The RMS packet on the top right, for instance, that's connected to the entire system also via RMS relay. Is that correct?
Correct. Yes, that's my UHF gateway. That's connected to RMS relay. And again, if you find that you connect and you'll notice here, this sentence right here says HF auto forward if no internet, and you will actually get a message directly on the screen when you connect to my gateway if the internet is down. So that's an important thing to remember. Oh, one thing I do want to mention here, and this is a little complicated to explain, so I hope I don't lose anybody. If the internet is down at my location, and one of my local folks here connects to my VHF gateway and wants to send a message, it'll say, whoops, there's the connection.
There's Mike.
Vera 500. Let's see if it's successful. I'm going to keep going if you don't mind while this is trying to connect.
Yeah, absolutely.
That person successfully sends a message to my gateway. The internet is down. So my connection will say it will automatically HF forward. Now, suppose the message that he or she just sent was addressed to someone else local, and that local person also connects to my VHF gateway. Guess what? They are not going to get that message until my internet comes back. Now, the gateway will hold the message, but they will not receive that message until my internet comes back. And this is talking about 2 local people here. If the first local person had addressed the message to someone outside of the area, everything would be fine. That message would be HF forwarded to the next gateway that I can connect to that has internet, and the other person could connect on VHF and receive that message. Now, I probably confused the heck out of everybody there, but did you understand that?
I think we did follow it, but Oliver might be able to map that out on the next slide a little bit too.
Okay, you can see the connection going on here. We'll see if it continues.
Mike had to switch over to 40 meters, as you can see in the dial frequency on top, right?
Right, there we go. There's his range, 490 kilometers. And I wish the heck that RMS tri-mode had the ability like Winlink packet does to change to miles instead of kilometers.
No.
Yes. And the bearing is 274 degrees true. And you'll notice at the very bottom line here is the connection summary. First of all, it's disconnected from KM6KAQ and it gives UTC time. It says CMS link ended. And the connection summary is the date, the time. The mode was Vera 500. He sent 218 bytes, and my system sent 87 bytes to the CMS, which is the central message server. And the last command was FQ, which is your disconnect, and the session took 2 minutes. So there you go.
Okay.
And thank you so much, Mike, for that live demo.
Yes, thanks, Mike.
Great interplay between Doug in Arizona and Mike here in Altadena. So, I mean, congratulations. This is what teamwork is all about. And it goes to show you that with Zoom and with amateur radio, we can actually cooperate across great distances. So fantastic.
So 2 data points for you with the 40-meter contact. Mike was using 100 watts right now. A few weeks ago, Tom said that he could connect on 40 meters using 10 watts.
And again, HF propagation, you know, it's a crapshoot, to use a kind of gross term, but that's what it is.
And in this case,
Okay.
let's go back and Doug, if you want to, you can walk us through this here a little bit. So this is RMS packet, right?
Yes. Yes, RMS packet, the Vera FM or packet connects to that, and actually tri-mode does as well, the HF side. And it in turn, oh, I'm sorry, there's the relay. I was thinking that was relay. Yes, there's the relay. Tri-mode connects to relay and RMS packet connects to relay. And also you can connect via mesh to RMS relay. And it then transfers information to the internet, which in turn goes to a CMS or central message server.
And that's a really powerful setup because the nice thing here is when the internet disappears, right? You have thought of that already as part of your local response. What happens?
Yes, and I might say something about that right here. You know, at some of our gateway locations, and I'm talking when I say our, I mean Yavapai County Aries Races. At some of our gateway locations, we have T1 lines or very, very robust internet connection. At my house here, I live in a rural area again. My internet is via actually mesh. The company uses mesh. They use commercial mesh frequencies to transfer internet to my house. And so my internet connection is not as robust as I would like it to be. So there is always the possibility of it going away. And not so much at my location, but at the point that feeds me. If the power goes out and the batteries run dead, you know, so things like that. Also, you know, you notice at the bottom on tri-mode, we have the 3 different modes of HF, Vera HF, RDOP, and PACTOR, which I do not do again because of the prohibitive cost of the modem. So go on, Oliver.
One more question. What happens to, let's say, if Mike sends a message to your gateway, he's got a successful connect and there's no internet?
If there's no internet, then my system automatically reaches out to KO000, K7DAV, or one of the other gateways that it can connect to, and whichever one accepts the connection first, it will pass that message to that gateway that has internet connection, and that gateway will transfer the message to the internet.
So it's auto forwarding. So take a deep breath, everybody, and think about this for a moment.
Yeah.
How cool this is. Using HF frequencies and forward it to another station and keep going until there's an internet connection.
That is with no intervention from me whatsoever. Does this all automatically. I don't even have to be at home. And again, keep in mind those special HF frequencies that are allotted to automatic HF forwarding. Years ago when Packet first started, and when HF Packet and things like the early Pactor 1 and Amtor and things like that first started, there was no such thing as automatic HF forwarding. It was illegal. But they finally talked the FCC into allotting certain frequencies for automatic HF.
Perfect. And that adds to the robustness. All right. You want to talk about that for a little bit?
This is a favorite screen of Oliver's and mine. Please keep this in mind. Mind your downstream circuit capacity. And what do we mean by that? Well, if you guys in LAX have an event going on and you're all at different hospitals and you want to connect and send messages back and forth on Vera wide, and all your stations are capable of doing that, go for it. But what happens if you need, as Oliver showed in one of his earlier screens way back, if LAX needs to go outside of area and start connecting to my gateway, my HF gateway, to send message traffic from the LA area? What's going to happen to your 120 kilobyte picture that you just tried to send or did send via Vera wide? What's going to happen to that picture when it gets to my, or even to the HF gateway in LA? What's going to happen? Well, I can tell you what's going to happen. It ain't going to happen. Look at this chart here that Oliver has. You can see Vera FM wide and the speed it's capable of. Narrow Vera, Vera HF 2300. You can see that greatly reduced. Vera HF 500 is really reduced, and at the bottom of the barrel is conventional packet.
So Doug, you're telling us don't gorge ourselves before we try to get into the corset at the end of the path?
Yeah, that's basically it, Tron. That's a good analogy. You know, sending normal message traffic, and again, to reiterate something that Oliver talked about way back at the beginning, was the fact that when they developed the Did You Feel It form, they kept it very small. And that's the reason for the specialized ICS forms in Winlink. So they are very, very small, and all that's being sent is the actual data that you enter. The form is in the software, so it populates the form on the other end when it's received. You're just sending the raw data that you have entered. And the reason for that, again, is this, this traffic pattern here. If those messages have to be sent over HF, you know, that's very important to keep that message as small as possible. And here's another even more stellar example as mesh in comparison to even Vera wide. Look at that. You know, we can send stuff on mesh, like, for example, when we did a demo a couple of years ago to sell our mesh system to our local hospital here, we actually sent a live EKG over mesh between the hospital and my home here. I had people from the hospital at my home, and we sent a live EKG. You should have seen the look on the faces of the two people that were here from the hospital when they saw that live EKG come across the mesh screen. It was like, wow, you know, this unbelievable. But again, that was mesh. That's comparing apples and oranges, to put it simply. And here's another very important thing that Oliver and I talked about yesterday, and we added this slide. Whenever you connect, whether it be via HF, by VHF, by a VHF Vera narrow, via Vera wide, whatever, the message you're trying to send should never, ever, ever exceed 5 minutes. Shouldn't even be that long. 2 to 3 minutes is the max. If you're starting to run into an excessive time trying to send that message, there's one of two things wrong. Either your message is way too big, or you've got a problem with multipath or a connection problem between the two stations. So if that's the case, you need to either rewrite the message in some form that's going to be transmittable via packet, or find another station to connect to that's got a better connection. And how you can monitor that is a little bit difficult in Winlink because you can't see the raw data. I talked earlier about looking at raw data on APRS. I always like to look at raw packet data because you can see the frames that get rejected. All of our messages sent, whatever they may be, pictures, messages, whatever, all of these packet systems have what they call automatic forward correction. So if the unit sends a packet and the unit at the receiving end doesn't get that packet completely, it sends a reject, and the sending station resends it. That could be a very reason for your connection to go longer than 2 or 3 minutes. So again, it's hard to determine that in Winlink because you can't see the raw data. But if you're running a VHF system and you're running UZ7HO with a signal link, for example, you can see the raw data on that UZ7HO screen. Start looking for those reject frames. It says REJ0 or REJ1 or something like that. And that will be a good indicator as to what's going on with your attempted sending of that message. I can't stress this. You should
So
never.
Doug, from your standpoint, when you see those as the sysop, do you push the button, say you are the weakest link, and reject them?
I have done that. As I told you and Oliver yesterday when we talked, one of our local members here tried to send a message that she had formatted incorrectly. She was trying to send a PDF of a form rather than the form in Winlink, and it just was a reconnect and reconnect and reconnect and retransmit. And I finally manually disconnected her from my system and sent her a text message and said, you know, there's something wrong with the way you have this message formatted. So I actually talked to her on the phone and we got it straightened out. So again, this is very important. Never tie up a gateway for over 5 minutes, because especially in an emergency, that could be absolutely disastrous. So can't stress this enough.
Yeah. And then here's the power outage one where we can cycle back to the power.
Yes. What happens when the power goes down at my station? It happens. You know, we're out in a rural area. We do have power outages occasionally, although not many. Again, we talked about this a little bit yesterday, but I'll go through it briefly. My system again is on solar and battery. I'm going to increase the solar and battery power, add more batteries for the radios. That does not take care of the computers. The computers are on UPS battery backups, and they have 2 batteries in them, and they only last so long. So I do have a generator. That's all well and good if I'm home. I will usually let the power be out for about a half an hour to 45 minutes before I start the generator, because I'm waiting for it to come back on. If it doesn't, I'll go out in the garage and haul my generator outside and connect it and get power back to my shack and get everything powered back up. But what if I'm not here? Well, guess what? My gateway could go away. So if you're not getting a connect to my gateway during some sort of event or emergency or even training, you might want to go to the Winlink site real quick and look at who's active right now. Because if I'm not active, my gateway's not going to show up. So that's something. Also, again, Oliver and Tron and I talked about this yesterday. When I'm out of town, our family all lives in Colorado Springs area. So we go up there at least once a year and visit. And I may be gone for 10 days or 2 weeks at a time. How do I monitor my system? Well, thanks to our wonderful computer technology these days, I use AnyDesk, just another program out there. And I will log into my gateway via AnyDesk from Colorado Springs and take a look at my system and make sure everything is working correctly. And if not, I can reset it remotely. And also my computer, my gateway computer is set up so that if the power goes out and my battery backup runs out and the computer shuts down, as soon as the power comes back up, the computer reboots and opens all of the programs automatically. So that's kind of how I operate.
And Doug, that was our last slide. And with that, I'm stopping my share, and I would like to thank you on behalf of Aries LAX. You know, this is fantastic. This was really eye-opening for me. I learned, we had a test session yesterday, but I learned a lot today as well. And let's open it up for questions if you have a couple more minutes.
Sure.
Anybody have any questions? Please raise your hand and, you know.
When are you going on the road?
Joyce just asked me when I'm going on the road to do this.
Well, it is a class act, so I think you definitely should take that on the road. All right, I think you answered pretty much most of the questions. So, all right. With that, thank you so much, Doug. Please feel free to to stay on and join us as we go through the next couple of topics. Is that okay?
I'm going to. Thank you.
Please.